We had just been talking about inscribed angles, so we know that inscribed angles are half the degree measure of the intercepted arc, or you could say that the arc is 2 times the inscribed angle measure. Now, along those lines, we want to look at polygons. Okay, so I'm going to start with a circle, and I'm going to construct an inscribed polygon. Now, do you remember what that means, an inscribed polygon? Or actually, I'm going to do an inscribed quadrilateral. Well, an inscribed polygon, and most specifically here I'm doing an inscribed quadrilateral, is when you have all of the vertices of that quadrilateral or polygon lie on a circle. Okay, so this circle is circumscribed the quadrilateral, which also we can say that this quadrilateral is inscribed within the circle. Now, there's something interesting that happens because of the inscribed angles. Now notice, how many inscribed angles do we have here? Hopefully you said 4, because all of the angles of the quadrilateral are inscribed angles. And we know that inscribed angles are half the degree measure of their intercepted arc. So this angle here that I'm looking at, let me name it for us. Angle ABC. Okay? Angle ABC is an inscribed angle. Its arc, if I name that point there, its arc that it intercepts is arc ADC. And I could actually construct that arc so you can see that a little bit better. Okay, so let me make it bold. I'm sorry, I like to make it stand out a little bit. Make it red and make it dark. Let's do medium. Okay, so if I were to trace out angle ABC, the endpoints of the angle are A and C. They then intercept this arc, and we make arc ADC. Now, we can verify that this angle is in fact half of the arc. So we can measure the angle, see that it's 81.2. Let's measure the arc angle, 162. So approximately, yeah, definitely double. Okay, you could actually see those are pretty good numbers. Now, thinking in terms of the actual quadrilateral though. Okay, so let me, let's hide this there. Okay, so we're looking at this circle, okay, and then the quadrilateral inside. We already have the measure of angle ABC. If I were just to then, let's say, measure the angle, the other 3 angles. Okay, I'm going to do this kind of quickly here. And I need this guy. Okay, and let's put them where they belong. So ADC is 98.8. ABC we know is 81.2. That right there, and that right there. Okay. Now, there's a relationship happening between the angles of this quadrilateral, and I'm going to try to manipulate some numbers here by just moving about. Ooh. Let's see, maybe we could do this one. You see what I'm getting at? I'm looking at most specifically these opposite angles here and here. Those are opposite angles. And we can look at these opposite angles. Anybody see a relationship? Look closely. Okay, let me help you out. Let me bring up the calculator. And I'm focusing on opposite angles. So I got those 2 opposite angles. Let's do another one, the other set here. Wow, look at that. Would you look at that? What do you notice about those angles? They're supplementary. Opposite angles of an inscribed quadrilateral are supplementary. That's very important. Write that down. The opposite angles of an inscribed quadrilateral are supplementary. Now, it's your job to tell me why that is, and I'll leave you with that.